So welcome to my channel on technology space with machine learning and artificial intelligence. So the today's topic is key pillars in autonomous shipping. And this is also part of the main playlist of maritime technology. So let's move on to the main content of this presentation. So let's talk about the key pillars in autonomous ship navigation. So the first key pillar we are going to consider in this presentation would be human navigator. I think human navigator would play an important role in autonomous shipping, even though that element is missing in many research studies. So we believe human navigator will play an important role in autonomous ship navigation since their skills will be cloned or utilized towards creating this digital navigator. So this is what done in the automotive industry, where the drivers' driving skills being cloned through deep neural networks to create that digital navigator. So eventually this type of digital navigators can be utilized towards autonomous ships, where we mimic human navigator behavior and capabilities to make the autonomous navigation is a reality. So the next key pillar is the technology. Here we are referring to the navigation and automation systems in ocean-going vessels. So the human navigator should interact with these relevant navigation and automation systems to achieve that navigation objectives. And then these objectives can be following a specific route and maintaining heading and course by controlling and speed and steering conditions of the vessel. However, when the human navigator is interacting with the technology, there's a main requirement to be illustrated, which is the information visualization, because the information the human navigator is obtaining through these technologies should not be overloaded or beyond his processing capabilities. So because of that, the information visualization would play an important role, because you should have that information of the navigation and automation systems should be available as visual aids to these human navigators adequately to support achieving the same navigation objectives. So the next key pillar is the navigation rules and regulations. So ship navigators should always comply with the respective navigation rules and regulations in the ocean. And this is kind of part of their training process. And finally, the last key pillar would be AI, or the digital navigator. And this digital navigator is a creation of cloned human behavior. So we believe that future autonomous ships will be guided by such type of digital navigators, and this would be created by human knowledge and experience in ship navigation. So because of that reason, this process being categorized as human training and AI learning. So if I say a little bit more about creation of this digital navigator in the automotive industry, what has happened was the human drivers data sets being collected, and then these data sets being utilized towards deep learning type of frameworks to clone this human drivers behavior. So similarly, we would believe that real world ship navigation data sets will be collected, and then human navigators knowledge and experience will be cloned through the deep neural networks, and then these neural networks become the representation of this digital navigator. So at some point, this AI and the technology should interact. So that means the digital navigator should interact with the navigation and automation systems to make this autonomous ship navigation is a reality. And this is kind of open research area. I think we have quite a lot of work to be done. And during this AI and technology interactions, there is a requirement that the information coming out of this navigation and automation systems should be presented towards the digital navigators in a way the digital navigator could understand that information. So information visualization towards the digital navigator can also be an open research area still, and that has to be formulated properly to make, again, this autonomous ship navigation is a reality. And finally, The navigation rules and regulations should also be complied by the digital navigator. So that way we can have a single regulatory framework for both human navigators in manned vessels as well as the digital navigators in autonomous vessels to be implemented in the future ocean navigation conditions. So one more note on this slide, some of the information visualization techniques and the regulatory compliance requirements would be developed as decision support systems, and this would be a kind of part of these digital navigators in the future. So let me say a little bit on this trustworthiness of AI. So here we are looking into the digital navigator from software level as well as the hardware level. So if I'm talking about the software level as the AI codes, these AI codes should have three main features. So the first one is fairness. That means no bias towards different conditions. And then the second one is the transparent. That means there must be explainability within these codes on when you're having a digital navigator. And then the responsibility. So this is the accountability of the digital navigator itself. So these are the features which we can discuss under the software level. So let me move on to the hardware level. Here I am referring to the systems and technologies. In general, resilience and availability should be available under the hardware level. And then if you're looking into the overlapping region where both software and hardware level should have these features, and that could include the reliability, privacy, security, and safety. So these are kind of additional four conditions which could overlap both hardware level as well as in the software level. So when you combine all these features, that would create this trustworthiness framework for digital navigators. And at some point, both human as well as AI would interact. So that means the human navigator as well as the digital navigator would interact in an ocean environment, which is called a mixed environment, where these human or the manned vessels and autonomous vessels are navigating. So that environment could possibly create various chaotic situations. I mean, this could be due to lack of information where improper situational awareness has created, and then partially that could also be some level of regulatory failures can happen. So because of these challenges, I think these initial mixed environments going to be somewhat challenging, where we need quite a lot of research to be done in the future. So that's the end of my presentation. Hopefully you have enjoyed it. So if you are still interested, please stick around. Thank you.